look at a whole range of things you get with FIR type filter responses, FIR type of processing responses. And some of it, the best way to figure it out is just to actually look at a couple different examples. And what we're going to look at here is just having two different impulse responses, very straightforward ones. One where it's a sum of two things, which is kind of like a low pass response, and then take a difference of it, which is going to be kind of a high pass response. You might also think it feels like a differentiation. And just to kind of see what happens when you do that. Because with a low pass response, it's going to feel like you're going to be smoothing things. Well, take a look at what happens when you take this input and you pass it through there. One, it actually does makes the response one step longer, because it's always going to be the convolution of the input, and then that plus the length of the convolution of the filter, and then -1. And so you're going to get something very much like this. And notice it smooths. In fact, notice this one at the very top at 8, because you get sort of this gain of 2, but it's at 8. It gives you kind of this, it comes up and it just kind of starts to round off, and then it comes back down sharp and falls back down. So very interesting response there. Well, take a different one. Imagine when I get here where I get this big jump initially at 3. It basically looks like a constant drop and then a jump up. Well, notice that I see some things with these jumps. I see an initial jump that's up pretty significant. I see another jump that's pretty significant. That relates both to this one and this one. And notice where they're sitting. One is right at the beginning, and one is at step 7, which is right after this occurs. Okay? And so this is really cool that I get those two things. But what happens in between? Well, I get a drop that's -1, because I'm dropping down by 1 all the way down. So you can start to get some real intuition of these kinds of filters, and that's a lot of what you're trying to look for. What happens when I have a low pass filter, so the low frequencies are going through, so it kind of smooths out, gets some of the high frequency stuff out, or a high pass filter, where it's going to be, I'm going to get the higher frequency things are going through, that changes, but anything that's kind of constant disappears. You could also say this has more of an integrating behavior. This is more of a differentiating behavior. And you see that a little bit here. Imagine if I have just a step up and going down. When I go through the summing case, which is the more integrating case, it comes up to 1, comes up to 2, still stays nice and flat, comes down. It looks like it kind of smoothed these edges off a little bit. Kind of cool. What happens when I do the difference? Well, what I notice is I get the step up, and then everything doesn't change, which is kind of a useful filter, because it basically says, well, nothing's there, nothing's changing. So I can see this one up, and then this went down, and everything else is 0. And so it's neat to kind of see these kind of dynamics. So there's a lot that you can really build and work with out of all of these systems.